Okay, hello everyone and welcome back. In this video, our goal is to show you how to use, how to actually add existing templates, project templates for Atmel Studio 7 and add them to your own installation of Atmel Studio. So in the previous video, in lecture 1, assuming that you saw that, among the many things that you were shown how to do was how to create project templates. And the templates, if you recall, stored all the settings, all the information, and some initial code listing that you could just use right away. So you didn't have to create the entire project from scratch. To compound matters and make them a little worse, it was explained that for our course we need to create a two-project solution. Right, we needed to have two projects because one project was targeting the Atmega 324P for simulation purposes so that we could debug our code line by line, and then another project was targeting the AT90 USB 1286 because this is the actual microcontroller that is on the actual physical hardware that you're going to be using, okay, which we call the target. Right, so you learn how to do that from scratch, and I told you that once you created the templates, that you could go ahead and save the templates on the flash drive, and then maybe you could come into the lab and then you can go ahead and import the templates. But I never actually show you how to actually import the templates. So the purpose of this video is I'm going to show you how to import the templates. And there's another reason why I want you to use our templates. We will provide these templates for you, and they will be posted on Blackboard for you to download from. Okay, you know, when you do the previous video in lecture 1, everyone will pretty much will be successful, but they will probably create variations of their own templates. So everyone will have many variations of the same template, and sometimes they may have different or erroneous settings that can cause issues when you're trying to execute the labs. Okay, and we want you to try to do those things by yourself so that you can customize the templates on your own. But to avoid problems, and as you learn to build confidence and whatnot, and to save you time when you're doing the labs, we provide the templates so that everyone is using the exact same templates, and you can get the job done and not worry about whether you got the templates correct or not. Okay, it's a skill you got to practice, but we also want to make it convenient so that you can use your time effectively. So in this video, I'm going to show you how to remove any existing templates you may have. Notice that if you're doing this for the very first time, you're not going to have to do the initial step I'm going to show you, but in the future you may have to change the templates. So you may want to delete the existing templates. I'm going to show you how to delete the templates also. Okay, and I'm going to show you some minor changes that I added that are slightly different from the templates that you saved in the previous lecture video, and I'm going to explain the reason why this is necessary. Okay, so let's go ahead and get started. So if you recall from the lecture 1 video, you will always have to start by creating an empty solution, and you will always do a two-project solution whenever we have to deal with both. We have hardware, and the hardware is the blue board that we're going to be using in the labs. Okay, so just to show you real quick, if I were to go here and just pretending, just to show you, remember I started with a new empty solution here, but if we look at the templates, I created two templates, and one is a template for my simulator project, and the other one is a template for my target. Okay, so let's pretend that you don't like these templates and you want to change them because they don't work, or you want to upgrade them or whatever. We gave you new templates. Say I made an error and I updated some new templates and I posted them on Blackboard, and you got to update them. What do you need to do? Well, let's assume that we have to start from that point. First thing, we got to locate the templates. So usually they are in your installation. If you go to my documents of your, and you find Atmel Studio, and I have both version 6 and version 7. In version 7 there's a folder called templates. Okay, and we go to project templates, and here are my assembler templates. So I'm just going to go ahead and I'm going to remove them for the time being, and I'm just going to put them here on the desktop. Okay, and just to show you, so they're gone. I'm going to go ahead and minimize it. I'm going to exit. For the any changes to templates to take place, you have to actually exit out of Atmel Studio, and then you have to restart it again. So I'm going to go ahead and restart the template, Atmel Studio 7. Wait for it to start. And again, just to verify, I'm going to go File, New Project, and under Assembler there's no more projects. Okay, so now you know how to remove them. But again, if this is your first time, you don't have nothing to remove anyways. So let's go ahead and exit. And once again, let's assume that you went to Blackboard and you downloaded these two files. So I have a project template for my simulator. Notice that they end with a .zip extension. These are zip files. And then I have another template for my target. Okay, so you downloaded them from Blackboard and they're somewhere on your computer or a flash drive or your desktop, whatever. Okay, to import the templates so that you can use them, you go ahead and start Atmel Studio. And come on, Atmel Studio. Usually when I'm running the recording video software, it interferes with my clicking capability and it just makes it difficult. But here we go. Okay, to import the templates, we go to File, Import, Project Template. Okay, select the project template, find them. I'm going to go to my desktop because that's where I have them, and I want to import the simulator, and I click Open. And you should specify the root. Okay, you could create some folders of templates and whatnot, but let's just go ahead and specify the root here, and let's go ahead and click OK. And it says template has been successfully imported. We're gonna go ahead and import the second template. Import file, import project template, select the template, assemble it for the target, click Open. We're gonna go ahead and set that at the root, click OK. Successfully imported. Now we File, Exit. To exit the application, we go ahead and then restart it. If I can restart it, it won't restart for me. Let's just right click and open and start Atmel Studio 7. Then let's say this is lab 2 or lab 3 or whatever. Let's just say lab 2 and you're starting now. So just to refresh on what you need to do for this class, we will go ahead and start with File, New Project, and select first. Notice that our projects are now available, so they're there, but we want to do Atmel Solution, and we want to start with a blank solution. We always start with a blank solution, and let's say we have let me make sure that I don't have that lab already saved. So I have a delete me. Let me delete these two, because otherwise I'm going to have issues. And let's just pretend. So let's suppose you're working on lab 2 activity 1. So try to use, this might be different from what I showed you in the previous video, but let's try to do lab number dash and activity number. So lab 2-1 for activity 1 underscore solution. Okay, click OK. Always be mindful of where you're saving your project. Click OK, and we have an empty solution. There's nothing to see. Okay, here's the Solution Explorer. Alright, so to add a new project, we right click and we go Add New Project. Do not go to File, New Project, because this will completely start everything from scratch and you will lose your empty solution. So instead, right click on the empty solution, add new project, and let's say we're working on lab 2. So we look at assembler projects for the time being, and we do lab 2-1 for activity 1 underscore simulator. Okay, I'll leave everything at its default, and make sure we select simulator project. That's very important. Don't forget to select that, and then click OK. And then a new project will be created. Notice that this is very similar to what you saw in lecture 1 video posted on YouTube. Nothing about this should be new except for these 3 lines of code, but I'm going to explain that in a minute. Then we need to add the target project if we're dealing with hardware or if the handout states that you should do so. Okay, the handouts that we give you might actually say we're only simulating, so we don't need to add a project. So therefore, if that's the case, we could stop here and we could get started to work. But if for whatever reason we also need to add the target project because we have some actual hardware we're going to be using, then we go here, click the solution, right click, add new project. This time make sure you select target project and give it the same name, lab2-1 underscore target, and click OK or hit OK. And notice that I have my simulator project and my target project. Please always make sure that you always add or start with the simulator project first. Okay, if you start with the target, what's going to happen is that the target will be the primary device, right? And then you will see all of these icons will correspond to the target device. We don't want that. We want all this to default to the simulator device, which is why we always have to start with the simulator project. If you make a mistake, and that is not the case, you could just select the simulator project, right click, and then click set as project default. Okay, and again, I know that that's my default because I have my right device for my simulator and it says simulator, and I already set that for you in the project template, which is why it shows. If you had done this wrong, you will see this. You will see that target would be the one in bolded black, and you will see the target device, which is correct, but there's no way to simulate. Okay, so if you make a mistake, right click, set as project default. And again, I gotta reiterate, if you add projects in here, always make sure you come here and you right click and select add new project. Never go back here except for only adding the empty solution, but never after that go back here and it says new project, because then you're going to lose your entire solution and you're just going to have one project. I always get this every semester. Some guy does that. Okay, we have the simulator and the project. Okay, and again, it's important that you always have the solution explorer open so that you know which is which, because they have the same name. I will refrain from attempting to actually click here and change the names of the files, because this creates a lot of problems that are difficult to find or resolve. Don't do it. Okay, the name uniqueness of the names should be on your projects, which is why I insist that you always add underscore simulator underscore target and underscore solution, so that you know your solution from your simulation from your target. Okay, let's go ahead and start with the project. So I mean with each project. So let's say you needed to do some debugging or write some basic code. Okay, now why these three lines? We have a new directive in this video, and that is .eq for equate. What this does is that it makes this literal string or identifier, if you will, underscore underscore DDRE to point to be equal to the actual register name called DDRD. This is the data direction registered on port D. Okay, pin E points to pin D, port E points to port D on the simulator. But notice that when we go to the actual target, DDRE points to DDRE, pin E points to pin E, port E points to port E. Why do we have to do that? Well, I'm just so glad that you asked. Let me explain. Okay, let me do a little bit of drawing here. So if you recall, the target device when we're using the actual blue board, and that won't start until like lab 3, 4, or 4, maybe 5. I can't remember. Probably lab 4. We have that device uses the 1890 USB 1286. Okay, if you recall, we always call this the target. Okay, and for simulation purposes, we use the Atmel 324P, which we use for simulation purposes. Okay, all microcontrollers, and you will learn this in a different lab. I'm just going to give you enough information for motivation. All microcontrollers interface with their physical world by way of what are called I/O ports. Okay, right? And microcontrollers have many ports. Okay, the At90 USB 1286 has a port A. I'm just going to write PA for short. Port B, port C, port D, port E, port F. I think it has definitely 5. I think it might have 6. I'm not really sure. You consult the datasheet, please. All right, and these ports communicate with the physical world, and each port has 8 lines. 1, 2, blah blah blah, 8. These are called I/O bit lines. Okay, and basically you could set this. You could actually use instructions in your program to set to this to some 0, 1, 0, 0, 1, 1, or in physical units, 0 volts, 5 volts, 0 volts, 0 volts, 5 volts, 5 volts to turn LEDs, activate motors or whatever. Okay, and for the blue board, for the Mega 324, because it's not exactly the same device, we only have a port A, port B, port C, and a port D. For sure, I know this for sure. So you only have 4 ports. So we have a little problem. On the blue board, this port is connected to a series of dip switches. Okay, there's a little bit of a set of a dip switch with 8 switches. Okay, so you can switch the switches from off position, on position, so that you could generate whatever pattern of bits you want, and then you read that inside of the microcontroller and store it in some kind of register. So for example, you could do something like use the in instruction. So it says read from an input port into R16 the contents that are on pin E. This means input port E. So we're going to read, because we're reading into the microcontroller, we have to use the pin E. Okay, and and then you have the data in R16, and then you analyze and you do whatever you need to do, and you can check the individual bits. But we have a problem. I cannot use the same instruction for my Atmega 324 because it doesn't have a port E. So if I say pin E, this is going to generate an error. Okay, so how do we get around? Because I said we need a way to test our code here using this device, and then copy and paste it here with minimal changes or almost no changes at all, so that it works here. Well, the trick is to use the equates. Okay, so notice that on my simulator project, my E registers, let me go back here again. From a physical standpoint, I only have, you have port A, port B, port C, port D, but from a software perspective, each port, let's call this port N, has 3 registers. It has a data direction register N, so where N is A, B, C, D, blah blah blah. It has an output port to output stuff out of the microcontroller, and it has an input register for reading stuff into the microcontroller, which is what we use here. Okay, so that's why we have 3 equates here to redirect. And so the idea is, let me show you, is if I type code, a simple line of code here where I say, first you have to configure the directions. Okay, but I'm not going to show you how to do that because that's not the point of this video. But if I wanted to read data from port E, because the equates already point to the right dummy port, I can just say input into R16 the contents of pin E. Right? And that's all I want. And actually I wrote this in the wrong place. Let me undo that, because this is for data. The code goes here. Okay, input into R16 pin E. Okay, but notice that now if I build the simulator, okay, and I start the debugger and break, and there's only one line of code here. Okay, and I step over by clicking or hitting F10, or remember hitting these icons, step over or step into. So hit it once, and I'm going to read pin E. Before I read pin E, I can open the I/O registers. So if I open the register by clicking the I/O icon, I can see the registers here. Now here my port A, port B, port C, port D. On my simulator there's only 4 ports. If I click on port D, because in the end my pen E is actually a name that points to pen D. I can go ahead here, maybe I can click, I can pretend, let's say I have F0 in hex, right? After I execute this line of code and I click step over, I can see that R16 indeed has F0. Okay, then I can stop this, stop the debugger. Looks like it works. But the beauty of this is that once you've written your code, it doesn't matter how long your code is, once you've written your code, you just copy from the ORG directive down to the exit. Do not mess with the stuff above it. You copy, and I can just go ahead and replace this, Control V to paste, and I Control S to save. And if I build my project is going to work just fine. Notice that I have no errors because my underscore pin E on my simulator is actually pointing to the correct port. Actual port is pin E. Okay. Now I should point out that if we weren't doing any of this trickery that I'm showing you here, the correct way to do this is to use the actual name. Okay. But because we want to avoid this issue of getting errors, and then we have to, if we didn't do this, if I didn't have this, I would have for this program to write pen D, and then after I copy paste this into my target, I would have to find every instance in my program where I had pen D, or do a control F and replace, and then change all my pin D instances to pin E so that I don't get an error, right? So the best way to do that is to simply have the equates always work for you and not have to worry about whether you're on the simulator or on the target. The equates, they take care of switching one from one to the other. Now, for all the other ports, you don't do this for all the other ports. For all the other ports, port A, port B, port C, port D, you use the correct names. You use, for example, pen, say, you want to say in R16, pen A, in R17, pen B, in R18, pin C, etc., etc. We only do this for port E because we have that equate that changes between the two. Now, if in the future there is a lab where we actually do require port D, what I recommend you do is that for the simulator project, change it to a different port, like maybe port F or port A. That you just basically assign this a port that you don't use, or that you're not using for that particular lab, and then that will do the trick. But do not change the target. Target should always point to all the E registers. Okay, saying for example, if I do output, let's say I do LDI R16 0x, let's do the dollar notation, 55, and then I want to output to R port A, R16. Notice that I don't use any underscores because I use the actual name. I don't have a problem there. The only problem is for what are we going to use to replace port E when we don't have port E as is demonstrated on here, right? Here I have nothing. So I have to pretend that whenever I need access to port E on my simulator, I have to have an imaginary port E that's actually pointing to one of these ports that is not being used. Okay, so that's it. That's basically how you import the zip files containing the templates onto your version of Atmel Studio at home if you have installed it on your own personal machine. And when you come to the lab here in the laboratory spaces on user computers, the computers, they usually reset at midnight into a fresh state. So every time you come to lab and you start a new lab, you need to make sure that you have these templates ready, downloaded from Blackboard, or already stored on your flash drive or your thumb drive or USB drive, so that when you come to the lab, you can just drop those onto the desktop, import them into Atmel Studio, and then you can get to work. Okay, so once again, as usual, I hope this is helpful. Let me know if you have any questions. My students know how to reach me, and that's pretty much it. Thank you for your time.